5, 4, 3.
Humans are explorers by nature. After visiting the most remote places on Earth, we recently went to space. But what if I told you that we don't need to go that far away to visit new places? What if instead of looking up, we had to look down at the chemical space, which is everywhere around us, except 1 billionth times smaller than a meter? In this unexplored nanoscopic space, there are no planets but atoms, which are bound together to form molecules. In my research, I'm targeting one atom in particular, fluorine. When fluorine is present on a molecule, it can make it more efficient. That's why today most pharmaceuticals and agrochemicals contain at least one fluorine atom. Therefore, it is important to find new ways to create fluorinated molecules, and this is the goal of my research. Fluorinated molecules can be divided into two categories. First, there are fluorinated molecules which are flat. These 2D chemical spaces have been thoroughly explored in the past. But when we had one dimension, it is harder to access the 3D fluorinated spaces. This is the goal of our exploration. But why is it so hard to set foot on these 3D spaces? To answer, we need to talk about an important concept in chemistry, which is chirality. Two molecules can look the same and be mirror images, but can't be stacked on top of each other. This small geometrical difference is going to have a big impact on the properties of the molecules. In your day-to-day life, this concept is also present. For example, our hands are chiral. They are mirror images but can't be stacked. As a consequence, we have a good hand, which we can write with, and a clumsy one. Let's take methamphetamine for example. This molecule is chiral. One form of the chiral molecule is like our good hand, and is currently sold as an over-the-counter drug for sore throat. But the other form is a hard drug, known as crystal meth.
I am the danger.
This is why, when exploring new 3D chemical spaces, it is important to only access the good form of the molecule. That is going to have a positive impact.
It's one small step for man, one giant leap for mankind.